Hello everyone, very good evening and welcome to the BYJU'S exam prep, the most comprehensive app for all competitive exams. Now guys, today we are going to discuss previous year questions of 2021, 2022 and 2023, right? And that is, we have started previous year question series because this time exam will be conducted by what? IISc Bangalore, right? And how you are going to get the pattern and what type of questions, right? It is possible to get the idea about the pattern of the exam, level of the questions by solving previous year question paper. So today we will solve questions from analog 2021, 2022, 23 electronics branch, and after that we will solve question from electrical branch because this analog is common in electrical and electronics. Okay, now let me know that sound quality, picture quality, everything is fine. Okay, I think now everything is fine now. Then this is my introduction. Myself Sanjay Rathi. I am having 22 years of teaching experience. I have qualified and selected for engineering services exam that is conducted by UPSC, and I have trained more than 1 lakh students for these competitive exams. And according to my experience, within this 4 months, you can get the top rank in GATE examination, right? बट आपको स्टार्ट करनी होगी अपनी प्रिपरेशन विद पॉजिटिव माइंडसेट. नेगेटिव थिंकिंग हटा दीजिए. 4 महीनों में आप रिजल्ट्स ला सकते हैं. ये है मेरा टेलीग्राम चैनल. यू कैन ज्वाइन माय टेलीग्राम चैनल, दैट इज इलेक्ट्रॉनिक्स बाय संजय राठी. आई विल अपलोड द पीडीएफ ऑफ दिस सेशन एंड यस्टरडे सेशन, और that was on network. Okay, so and if suppose we are getting some notification, then we will upload that notification on my telegram channel, that is electronics by Sanjay Rathi. If you want to join course, then this is golden opportunity for you. National scholarship test for GATE exam. Get up to 90% off on our program, that is on 1st of October, right? Coming Sunday. Note the time from 9 AM to 9 PM, means that window will be open for what? 12 hours. And you can start your journey with us, guys. Second thing, if you want to get the detail about the GATE, how last 120 days preparation strategy towards GATE 2024, then that is by Richa Gupta ma'am. Free workshop 27th of September at 7:30 PM, means tomorrow, right? So you can join. So very good evening, Harsa. Then now GATE 2021. So we will solve the question from 2021, 2022 and 2023. All the questions from analog electronics branch. Okay, and if you find any difficulty, then please ask. Now first question from analog, numerical answer type question, 2 mark question, right? And so that you will get idea that which type of questions, what is the pattern of the numerical answer type question, 1 marks or 2 marks question. So this is the first question in analog. Capacitor is connected here, 500 kilo ohm resistor is here, diode D1 is here, and one Vin is applied, that is a square wave. According to the shape, this is a square pulse. An asymmetrical periodic pulse train of 10 volt amplitude with on time 1 millisecond and off time 1 microsecond. So if this type of question is written, tell me what will be the answer. 1 millisecond on time, and this is the off time, it is only 1 microsecond, very small. 1 millisecond on time and so on. That is given. And what is the amplitude of that? 10 volt. This is the case. Applied to the circuit shown in the figure, the diode D1 is ideal. The difference between the maximum voltage and the minimum voltage of the output waveform V0 is. Very quickly you can give the answer. What is this? This is a clamper circuit. Once we are having the capacitor here, diode here, and watch this. This is a negative clamper. This is a negative clamper, and it will introduce a negative DC value. Negative clamper and negative DC value. Now, during charging of the capacitor, diode will remain on, but during discharging of the capacitor, the diode will be off. That is the procedure. Then what is the asked difference between the maximum voltage and the minimum voltage of the output voltage? Swing. So here, if it is a clamper circuit, you have to check only what is the conduction time and what is the non-conduction time. The conduction time means when the diode is on, and when the non-conduction time when the diode is off. When we are watching this waveform, during positive half, during positive portion that diode is on. This is called conduction time. Why conduction time? Because the diode is on and the capacitor will charge. And it will get sufficient time because this diode will act as short circuit, and this is the 10 volt. The capacitor will suddenly charge up to a 10 volt. And during this time, this is what 1 microsecond. Diode is off and capacitor will discharge through what 500 kilo ohm resistor. But during discharging time, what is the time constant? That is important. So you can find the time constant of the circuit during discharging when the diode is off. When the diode is off, what is the time constant? This is the circuit. The time constant of the circuit will become RC 500 kilo ohm 10 to the power 3 into value of the capacitance 20 nanofarad 10 to the power minus 9. Then you will get 20,000, 10,000 actually, 500 into 10,000 into 10 raised to power minus 6, and again that will become 10 to the power minus 4, 10 to the power minus 2 second or 10 milliseconds. Check my calculation. 10 millisecond. If you are getting the 10 millisecond, again this is the time constant is very large as compared to time available for what discharging, that is only 1 millisecond, only 1 microsecond. Was very large as compared to that. That's why the capacitor will not discharge. Once the capacitor will not discharge, it will hold the value 10 volt. When it will hold the value 10 volt, then this is converted into a battery. And what will be the output voltage? V0 will become Vin minus 10. This voltage will oppose the Vin and Vin minus 10. The complete waveform will come downward. And remember, you can directly give the answer, the swing will remain same. If the initial swing is 10, then what is the final swing? It will also remain 10 in case of clamper. But this is the on period, this is the off period. Everywhere you have to subtract what? 10. And so on. Okay. This type of waveform. So what is the highest value? 0, lowest value minus 10. What is the difference? 10. So answer for this question is 10, and remember it is a negative clamper, guys. Negative clamper. So one question from negative clamper in 2021, 2 marks. Numerical answer type question. Clamper is important topic. Note the topic. Second one. Second question. Negative clamper, positive clamper. Then second question on MOSFET, 1 mark question only, 1 mark. In the circuit shown in the figure, the transistor M1 and M2 are operating in saturation. Both are in saturation. The channel length modulation coefficient of both the transistors are non-zero. Means lambda is non-zero value. Means we have the output resistance for both the MOSFET. The transconductance of the MOSFET M1 and M2 are GM1 and GM2. GM1 and GM2 respectively. The internal resistance of MOSFET are R01 and R02 respectively. Then what is the question here? That is the diagram. PMOS, P channel, PMOS. Why PMOS? This is the direction. It is also a PMOS. That is the source. This is the drain of the second. This is the source connected. We are getting the output here. And this is the source. This is the gate. This is plus, this is minus. This is the VGS. If you want to calculate VGS, this is minus, this is plus, this is minus. VGS. And when we want to find the gain, what is this? Transconductance. What is the question here? Question here Ignoring the body effect, the AC small signal gain, AC gain, you have to find the gain that is given in terms of transconductance and output resistance, transconductance and output resistance of individual MOSFET. How we can find the gain here? With the help of a small signal model. What is the small signal model? Watch this. First of all, this is very important topic. During AC analysis, VDD should be equal to 0. So this point is connected to ground, means source S2 is connected to ground. Gate G2. What is this? V in. From this you can find VGS2. VGS2 is nothing but V in. VGS2 is nothing but V in. Now this is drain. This is the source. And now what is this VGS1? What is the VG0? So VGS1 is equal to nothing but VG1 minus VS1. 0 minus V out, and that's why it is minus V out. VGS1 will become minus V out from this point to this point. This is plus, this is minus. Now this model and this should be converted into what? A small signal model. So what is the small signal model? That is the small signal model. GM VGS1, that is the drain terminal, this is the source terminal, and here we are having output resistance R0. This is for this one. This is the source, that is the drain, and here it is the gate G2, and then this G2 is connected to what? V in. Already we have calculated the VGS2 V in. VGS2 is what? V in. And that's why you can write it as what? GMV in. Now, this is the drain of D2. This is connected to source of this. Then again, GM1 VS1. And output resistance R01. And we are getting the output here V0. Now, what is the VGS1? Already we have calculated minus V0. V0. Okay. And this gate is connected to ground, drain is connected to ground. So drain is connected to ground, gate is connected to ground. No problem. G1. And this is connected to V in. So that is the small signal model. Now from this small signal model, how we can find the output upon input? That is called gain. So write down the KCL, KVL or KCL. V0, what is the outgoing current? GM V in. What is the outgoing current? V0 minus 0 because it is connected to ground. This is the source is connected to ground, S2. V0 minus 0 by R2, V0 minus 0 by R01, and that is the incoming current. You can write KCL. So I am just writing. So what is the outgoing current? GM V in outgoing plus V0 upon R2, R02, V0 by R02 plus V0 upon R01. This is the V0 upon R01, and that is the incoming current. These all are outgoing current. This is the incoming. The incoming is minus, but it is also minus. So minus of minus GM1 V0 is equal to what? 0. Now watch this. V0 1 by R01, 1 by R02, and 1 by plus GM1, and that is equal to what? Minus GM1 V in. GM2 V in. This is the GM2. This is the GM2 because of second. GM2 V in. So in next page we will solve. This is equal to, you will get V0 1 by R01 plus 1 by R02 plus what? GM1. GM1, you can take common. Then finally, you will get V0 is equal to, V0 by V in is equal to minus GM2 into 1 by R01 plus 1 by R02 plus what? GM1. And that is nothing but parallel combination of this. So you can write GM2 is equal to 1 by GM1. This is the resistance. parallel with R01, parallel with what? R02. Unit, it should be unitless, that is we are getting the unitless quantity, and that should be the answer. Which answer is correct? GM2 into 1 by GM1, R01 parallel with R02, that is the answer, with 180 degree phase shift, because this is a negative answer, 180 degree phase shift here. So that is the answer for this question. Next one. So again it is a 1 mark question only. So directly by watching you can give the answer. By right, directly you can use, no need to draw the models and so on. With practice you can directly say that is what, that is the value it is connected toward the second one, that is the first one. We are taking the output here, right, and we are giving the input, that will act as a load. So R02, R01 parallel and GM1 in parallel, and that is the conductance of this, conductance of the second one, because input is connected here, right, and that's why directly you can give the answer. So GM2, that's why it is multiplied, because we are giving input to what? Second one. 1 by GM1, R01 and R02 are in parallel. Then next question again on what, 2 marks question in 2021, again MOSFET. First question clamper, then second question MOSFET, third question again on MOSFET. Then watch this. For the transistor M1 in the circuit zone, mu n COX is given, W by L aspect ratio is given, mu n is the mobility, COX is the oxide capacitance per unit area, W is the width, L is the length, the channel length modulation coefficient is ignored, lambda is 0. If the gate to source voltage is 1 volt, gate to source voltage is 1 volt. To keep the transistor at the edge of the saturation, then the threshold voltage of the transistor. What is the threshold? That is the question based on what? That is the question based on biasing. Yes, Hers. This is also important for electrical branch as well as electronics branch, right? But this type of question is more important for electrical branch. And yeah, tomorrow I am going to discuss all the questions from what electrical branch, so that you will get more clarity on that. Right now, this type of question is important because this is simply based on what? Biasing. Simply based on biasing. For biasing, that should be in saturation, at the verge of the saturation, means what is the value of the VDS? VDS should be equal to what? VGS minus VT. You have to find the VT. VGS is given as the question 1 minus VT. 1 minus VT. VDS will become 1 minus VT at the boundary of triode and what? Saturation. Then triode and saturation, to maintain the saturation, that should be the minimum value of VDS, or that is the, what is the condition for saturation? It should be greater than or equal to what? VGS minus VT. So exactly at boundary it is equal. VGS is given as 1 volt in the question. We have to find the VT. Then what is the VDS? VDS is the voltage from this point to this point. And what is this current ID? So what is the VDS? VDS is nothing but VDD minus ID into RD. What is the VDD? 3 volt. What is the RD? 20 kilo ohm ID. That is the second equation. That was the first equation. This is the second equation, that VDS is equal to 3 minus 20 ID. VDS is equal to, okay. Now, what is ID? Because it is in saturation, you can write saturation half of mu n COX, that is the K index, W by L, VGS minus VT. VGS minus VT. So what is the IDS is equal to half of mu n COX is given as 0.1 milliampere per volt. No doubt it is given as mu n COX 100 microampere per volt. So what is in milliampere? 0.1 milliampere per volt square. What is the W by L? 10. So you can use the 10 directly. So you will get W by L 10. And what is the VGS minus VT? What is the VGS minus VT square? So VGS minus VT square means what? VGS is what? 1 minus VT. Square of that. Now this will become IDS 10, 1 by 2, it will become 1 by 2, and then 1 minus VT write 1 minus Vt the square. That is the value. This is the third equation. Okay. Now guys, what we actually what is asked at the verge of saturation, what is the value of to keep the transistor at the edge of the saturation, then the threshold voltage of the transistor Vt is required. Okay, so how many equations we are having? The 3 equations, and the Vt is required, and to get the Vt you have to find the VDS. So you can replace, and there is the relation between what VDS and ID. So we are having the 2 equations, this equation and that equation. You can convert it into what IDS is equal to 1 by 2. What is the 1 minus Vt? 1 minus Vt is VDS. So you can write VDS square, right? And IDS is equal to 1 by 2 VDS square. You can put here and you will get the quadratic equation. VDS is equal to 3 minus 20 times of ID. What is the IDS? 1 by 2 VDS square. That will become now 1 minute. Okay. VDS is equal to 3 minus 10 times of VDS square. Okay, and you will get a quadratic equation 10 VDS square plus VDS minus 3 is equal to 0. From this equation, find the value of VDS and then put the VDS in what? 1 minus Vt. From that you can find the value of the Vt. Okay, around 0.5 volt. Remember, if you are going to get the 2 answers, definitely quadratic equation means you will get the 2 answers. But remember, Vt should be less than VGS or VGS should be greater than Vt, otherwise it will be in cutoff. What is the VGS? 1 volt. So that should be the Vt. If you are getting the 2 answer, that answer which one is less than 1 volt is the correct answer. So get the VDS from this, put here and you will find the Vt. Okay, then that is the question. I think around 0.5 is the answer for this one. That is the question on MOSFET. So already solved. Now next one. Next question is on what? Operational amplifier. Operational amplifier is always important for electrical or what? Electronics branch. Okay. So then what is the answer? For the circuit with an ideal op-amp shown in the figure, this is the ideal op-amp. Reference, V reference is fixed. This V reference is fixed. If V out is 1 volt, for V in is 0.1 volt. Second condition, V out is 6 volt, for V in is what? 1 volt, where V out is measured across RL connected at the output of this op-amp. The value of RF by Rn is. The value of RF by Rn, that is asked, right? But there is some ambiguity, so that we will solve this. And remember, in this question, this reference is fixed. So this voltage is fixed. What is this voltage like? It is Vp. What is the positive terminal voltage? R2 upon R1 plus R2 into what? V reference. This is constant because V reference is constant, R2, R1 constant. Now what will be the output? According to superposition theorem, output because of the non-inverting terminal is 1 plus Rf by Rn into Vp. This is the Rf by Rn into what? Vp minus Rf by Rn into what? Vin. Now this is fixed value. So you can choose this fixed value because Vp is fixed, gain is fixed. You can choose it as what? X. Then V out will become X minus what? Rf by Rn into Vin. Now what is given here? V out is 1 volt, for V in 0.1 volt. 1 volt for V in 0.1 volt. It will become Rf by Rn 0.1. Second, V out is 6 volt for V in 1 volt. 6 volt for V in 1 volt. 1 volt, okay. Now, this is the left, this is equation number 1, equation number 2. Subtract 2 minus 1, 2 minus 1, 6 minus 1, you will get the 5. X cancel out. Then you will get minus Rf by R1. 1 minus 0.1, that is the 0.9. Rf by R1 with negative sign. What is the Rf by R1? Minus 0.9, that is the 50 by 9, and you will get around minus 5.5555. So what is the mistake here? What is the mistake here, guys? Yes, Vikram, your answer is correct for the previous question. Why? Because when we are increasing the inverting terminal voltage, if these are the passive elements, they are not negative resistance, then definitely the value should decrease. But what will happen in this question? When we are increasing the voltage at negative terminal, we are increasing the voltage at negative terminal by 10 times, output is not decreasing, output increasing. Output is increases. That's why we are getting the negative value. So guys, it is a marks to all type of question. But if suppose only the magnitude is asked, then this is the correct one. Magnitude. But only the value is given. That's why it should be negative. But if only the magnitude, then this is the answer, 5.555. It should be negative. Otherwise, that statement is not correct. So sometimes we are getting ambiguities. For example, in 2023, 2 questions in analog. 2 questions analog, marks to all type. You can watch. Just I will give the idea. The next one. Next question. Again on operational amplifier, MCQ, 1 mark question. Quickly. Consider the circuit with an ideal op-amp shown in the figure. Assuming V in less than VCC, V reference less than V, very less than VCC, that is the V in is very less than supply voltage, V reference is very less than supply voltage. The condition at which V out equals to 0. Tell me what will be the answer and share the link of this session. Then suppose we want what is the output. In operational amplifier is a linear integrated circuit, so you can apply the superposition theorem. According to superposition theorem, output will become Rf by R into Vin. Rf by R into Vin minus. Why minus? Because it is a inverting Rf by R minus Rf by R into Vin. Second is again minus Rf by R into V reference, but that polarity is reversed. That's why it is negative. Minus V reference. Then it will become minus Rf by R V in plus Rf by R V reference, and that should be equal to 0. So Rf by R you can take common and you can say V reference is equal to what? V in directly. When the V reference and V in are equal, then we will get the output equal to what? 0. So directly it is a summer. It is nothing but a inverting summer, guys. It is a V in is equal to V reference equal. A is the answer for this question. 1 mark question MCQ, right? Remember, but there will be negative marking in what MCQ? There should right? So this is the case. Okay. Next question. GATE 2022. That is all about the GATE 2021. Now 2022. In 2022, first question again on operational amplifier. An ideal operational amplifier circuit with a sinusoidal input is shown in the figure. Sinusoidal input is here. This R, this is C, this is R. The 3 dB frequency is the frequency at which the magnitude of voltage gain decreases by 3 dB. Means it is decreases by 1 by root 2 of the maximum value. Maximum value. Which of the position options E's are correct? Means MSQ. It is not MCQ, it is MSQ. It is a MSQ of 2 marks. But it means there is no negative marking. So please give me the answer. Now remember, if RF is connected here and C and R is connected here, this is a high pass filter. Standard circuit for high pass filter. First thing. If the C is connected here and R is connected here, then it is a low pass filter. This is a standard circuit for high pass filter. Second, what is the frequency, cutoff frequency? In radian it is given by 1 by this R and C only. 1 by R, 1 kilo ohm 10 to the power 3 into C 10 to the power minus 6. That will become 1000 radian per second. 1000 radian per second. The circuit is a high pass filter. 3 dB frequency is 1000 radian per second. B and C is the answer. So for standard circuit, filter, always remember, filters are very, very important. High pass filter, low pass filter, band pass filter, band reject filter, all pass filter, right? And these all are what? Active filters. So already I have taken number of sessions. Again, you want some more questions, you can also install what? BYJU'S exam prep app. So on BYJU'S exam prep app, tomorrow 12 p.m. morning, right? 12 noon, afternoon, right? I am going to take questions from basics of network, theorems of the network, and what? Diode circuits. Then I will take questions on what? MOSFETs. Then questions on operational amplifier on app, BYJU'S exam prep. This is the answer is B and C. So you can install now, and for notification you can join my Telegram channel also. The next one, this is a high pass filter. Okay. Again the question on what? Operational amplifier, MCQ in 2022. For the following circuit with an ideal op-amp, the difference between the maximum and minimum values of the capacitor voltage. Where is the capacitor voltage? This one. This is the capacitor voltage. A number of diodes are connected here. But if you have idea about that, then you can solve. You can have the idea, then you can solve. What is the idea means? Means what? It is a square wave generator, right? Then you can solve. Otherwise, it is not possible to solve within 1 hour. So, it is a square wave generator actually, right? A stable multi-vibrator. So, what are the threshold voltage? So, you have to find the threshold voltage only. So, this is the positive feedback. There will be the two output only, 15 and minus 12. This is the 15 volt supply, minus 12 volt. When the output is 15 volt, the diode D1, because of the 15 diode D1 is off. Because of the 15 diode D2 is on, right? And that will be the diagram. Okay. Once you have this is off, this is on, you have to find the voltage at this point. And remember, what is the current enter into the operational amplifier? 0. So what is the first threshold voltage? Because this diode is on, it will short circuit the R. And this R, and this is single R. You will get, this is the positive terminal voltage, R 15, and that is R. So what is the VP1? R divided by 3R into 15. You will get the 5 volt. 5 volt is the first threshold voltage. First threshold voltage. Then second one, in second case, when we are having the minus 12 here, how we are getting that ideal diode? It is given in the diagram, that is the characteristics of the diode. When the diode is forward bias, what is the drop across the diode? 0. And when the diode is reverse bias, what is the current through the diode? 0. This is the current, this is the voltage. It is the ideal diode characteristics. So ideal diode characteristics minus 12, because of this it is on, it is off. When it is on, it will short circuit the resistor. This is the VP. This is resistor, this resistor are in series. This is the present, but it is short circuited. Then you will get, this is minus 12, this is R, this is R, this is R. What is the VP2? That is called second threshold voltage. So you will get 2R upon 3R into minus 12, minus 8 volt. What is the upper threshold? 5 volt. What is the lower threshold? Minus 12 volt. Now, if you have the idea about the square wave generator, then you can, yes sir, if you are having the upper threshold level and lower threshold level, so what is the voltage across the capacitor? Like this is the 0 level. Then upper one is lower one is -8. And the capacitor voltage will switch between these two. And that is the charging, discharging and so on. So what is the range of the maximum and minimum? What is the swing? 13 volt. 5 minus of -8, that is the 13 volt. That is the difference between maximum and minimum. So answer is 13 volt. This is the answer. The maximum and minimum values of the capacitor voltage. This topic is very, very important. Watch the last 20 years question paper. Number of times question on square wave generator or stable multi vibrator. Similar type of questions. Next one. So this is the next question. Now this is R, this is CR. Again filter, low pass filter. If we are having the RC circuit, it is given the diagram. This is again a low pass filter. Then circuit with an ideal op-amp is shown. The Bode plot for the magnitude of the gain transfer function of the circuit is also provided. Omega is the angular frequency. The values of R and C are. So R and C means what? This is given, it is a low pass filter. And we have idea it is a low pass filter because R and C. Then exactly at cutoff frequency, gain reduces by 3 dB. So gain is given in dB. 20 log of that, it is means gain is in dB. And it is the log of 10 omega is given. 1, 2, 3, 4. It is a log 10 of omega. So exactly at 3, the gain reduces by 3 dB from 12 to 9. From 12 to 9, it is decreased by 3 dB. That's why this is a 3 dB cutoff frequency. So what is the 3 dB cutoff frequency? 3. It is not radian per second. Log 10 of omega is equal to 3. And what is the maximum gain here? 12. So what is asked? What is the value of R and C respectively? Resistor and capacitor. Remember, for this particular diagram, cutoff frequency from this figure, the cutoff frequency is log 10 of omega. That is equal to what? 3. So what is the omega is equal to 10 to the power 3. Anti-log because 10 to the power 3, 1000 radian per second. Okay. Then what is the cutoff frequency? You can find from this cutoff frequency from this portion 1 by RC. Omega is equal to 1 by RC. 1 by RC is equal to 1000. So what is the C is equal to? C will become 1 by R into 1000. 1 by 1000 into 1000, that is the 10 raised to power minus 6, means 1 microfarad. The value of the C is 1 microfarad, this one. Second thing, what is the maximum gain? What is the maximum gain for this filter? Maximum gain for this filter is 1 plus RF by R1 because it is connected to a non-inverting terminal. So non-inverting terminal, so what is the gain? This is the non-inverting operational amplifier. This is the non-inverting operational amplifier, and exactly at omega equal to 0, this capacitor will act as open circuit. And for this capacitor when act as open circuit, what is the voltage at this point? V. And VU will get the output is equal to 1 plus RF. RF is R by R1. This is the R1, this is the RF. RF by R1 into V. And we are getting the maximum gain for low pass filter at omega equal to 0. So maximum gain, it is the 12, it is in dB. So it is in dB means what? 12 is equal to 20 log of A. Right, now you can find, so what is the A? A is equal to NT log of 12 by 20. NT log of 0.6. And you will get around 4. And what is A? 1 plus RF by R1. 1 plus RF. RF is R upon R1. RF is R, and what is the R1? 1 kilo ohm. Is equal to 4. R is equal to what? 3 kilo ohm. That is the answer. That is the answer. So you are giving the B option means, watch this, 3 kilo ohm and 1 microfarad. This is the A answer. 3 kilo ohm and 1 microfarad. So I have said now, filter is very, very important topic. Next one. Next question. 2 mark question. Circuit and the characteristics of the diode in it are shown. Circuit and the diode. This is the, now watch this. This is a practical diode, because when the diode is reverse bias, current is 0. But when the diode is forward bias, current is 0.7. In same year, two characteristics, 0.7 means it is a practical diode. Current will increase but the drop will remain fixed, that is the 0.7 volt. Means you can draw like this. When the diode is reverse bias, it will act as open circuit because the current is 0. When the diode is forward bias, it is converted into a battery of voltage 0.7 volt. Okay. Circuit and characteristics of the diode in it are shown. The ratio of the minimum to maximum is small signal voltage gain. Means minimum. What is the minimum gain upon maximum gain? Minimum to maximum voltage gain ratio, it is required. Okay. How we can find? How we can find minimum? For example, there are two cases, when the diode is on, when the diode is off. So there are two cases. So first of all, when the diode is off, you will get the maximum gain. So you can remove this diode. You can remove this diode when the diode is off. Diode is off means you can remove this diode. Open circuit. So we are getting the output across 2 kilo ohm, 2 kilo ohm. These 2 kilo ohm, 2 kilo ohm in series, and that is the total. So you will get simple output. dV naught by di. dV is equal to, what is the, according to voltage division rule, or suppose this is the differentiation, it is given, no problem. You can also find like this. What is the output is equal to 4 upon 2 plus 2 plus 2, 6 into V in. So what is, differentiate it to dV naught by dV in is equal to, what is the differentiation of V in? 1, 4 by 6, that is the 2 by 3. This is the first gain. This is the maximum. Second case, when the diode is on. When the diode is on, it should be replaced by what? 0.7 volt battery. 0.7 volt battery here. When the second case, the diode is on, because it is a practical diode, it should be replaced by the 0.7 volt battery. And now we have, it is a 0.7 volt battery. Then what is the output? Suppose you are moving in this direction. This is I. Let this is I. I is divided into two parts, I1 and I2. And again it will become I. Because we are adding the current, again it will become I. Now I write down the KVL in this loop. When we are adding the KVL, you will get V out is equal to 0.7 plus what? 2I. Now what is I? How we can get the I? Then you can write a KVL from this point to this point. KVL from this side to this side. So you will get V in is equal to 2I. This is the 2I plus what? 0.7. 2I plus what? 0.7 plus 2I. 2I plus 0.7 plus 2I, and that is equal to what? V in. Okay. Then from this you will get I, and then you can put here, or otherwise, okay, that is the method. So what is the I here? I is equal to V in minus 0.7 divided by 4. Put here. Then V out will become, that is the method I am just giving, 0.7 plus 2 times of V in minus 0.7 divided by 4. That is, what is the V out is equal to, that will become 0.7 plus V in by 2 plus minus 0.7 divided by 2. Okay. Now guys, if you want to find, then find, otherwise remember this is constant, this is constant. When we are differentiating it, when we are differentiating with respect to V in, what about the constant value? Differentiation of constant will become 0 and you will get 1 by 2, 0.5. That is called minimum gain. Change in output because of the change in input you have to find. Minimum gain. What is the ratio of the minimum and maximum? Then maximum is 2 by 3, minimum is 0.5. So what is the ratio? 0.5 means 1 by 2 divided by 2 by 3. So it will become 3 by 4. 3 by 4 is what? 0.75. The ratio is what? 0.75. This is the 0.75. Answer is 0.75. Okay, the next one. Next question is, consider the circuit shown with an ideal long channel MOSFET. Enhancement mode, substrate is connected to the source. Where is the substrate? Substrate is connected to the source. Okay. Substrate means what? Body terminal. It is not visible, but body terminal is connected to source, that is the S, and these two terminals are given A and B. This is the asked. The transistor is appropriately biased in saturation region. It is in saturation region. Then with VGG and VDD such that it is in saturation region. It acts as a linear amplifier. Vi is the small signal AC voltage. VA and VB represent the small signal voltages at the node A and B. The value of VA and VB. Value of VA and VB you have to find. Okay. When the value of VA and VB is required, remember how we can solve? A small signal model, or directly we can solve. I will give you the shortcut, but small signal model, with the help of a small signal model, when we are doing the AC analysis, it will be 0. It will be 0. All the DC sources will act as 0, means voltage source act as short circuit, it is act as short circuit. What is the small signal model for that? GMVGS1, GMVGS. And if the R0 output resistance, it is not given, early fact it is not given, you can take R0 as what? Infinite. GMVGS, this is the VG. G terminal, that is the S terminal. From S terminal to ground, we are connecting the 2 kilo ohm resistor. This is the 2 kilo ohm resistor, and we are taking the VB here. And from drain, this is the drain. Drain to ground, we are connecting the 4 kilo ohm. This is the drain. Drain to ground, we are connecting the 4 kilo ohm. And here we are taking VA. With respect to drain, VA, 4 kilo ohm. Now, this is the V in, it is connected here. So what is the ratio of the VA and VB? So what is the VA upon VB? It will become, what is the current here? Minus GMVGS. So you can write minus GMVGS into 4. And what is the current in downward direction? GMVGS. So what is the VB? GMVGS into 2. It will become minus 2. Answer is minus 2. Directly from the small signal model, you can say minus 2. This is the minus 2. This is the multiplied. This is the multiplied. But guys, no need to draw the small signal model. Directly you can say, for example, it is short circuited. It is short circuited. Because it is short circuited. Because it is a AC analysis. What will be the current? ID. Small signal. What will be the current? ID. Why? Because the gate current is 0. Now, ID is downward. So what is the upward? Upward will be minus ID. Now, from this point to this point, what is the voltage? Write down the KCL. So what is the VA? Minus ID into 4. Minus ID into 4. And what is the VB? ID into 2. Without a small signal model, what is the ratio of the VA by VB? Minus 4 by 2. That is the answer is minus 2. Directly from this diagram. But the small signal, this DC will be 0. This DC will be 0. And that ID will flow from drain to source. And then according to the polarity, you can write. This is ground, that is ground. Directly you can get the answer. Next question. Next one. Remember guys, you can download the BYJU'S exam prep app from our Google Play Store, okay? And then take part in what? Quizzes. We are having the mock test where you will get this leaderboard. Suppose there are 60 students, then what is your rank, what is your score, everything will be mentioned here. So that you will get the idea about your strength, idea about your weakness and what about your preparation. इतने सारे लोग देंगे तो उनके बीच में आपकी रैंक क्या आ रही है. इट विल बूस्ट योर कॉन्फिडेंस और आपकी प्रिपरेशन के बारे में बताएगा. तो आप डाउनलोड कर सकते हैं नाउ, क्योंकि कल 12 बजे मैं एक सेशन लेने वाला हूं ऑन बायजूस एग्जाम प्रेप ऐप. अब आते हैं गेट 2023 में. तो जितने क्वेश्चन हमसे सॉल्व हो जाएं वो देख लेते हैं. नेक्स्ट वन, in the circuit shown below, V1 and V2 are bias voltages. Bias voltages means DC biasing. DC biasing means DC bias in active region or saturation region. So these are the bias voltage V1 and V2. Okay. And then based on the input and output impedance, the circuit behaves as. This is a 1 mark question MCQ in 2023. Right. There are 4 types of amplifier. Remember, voltage amplifier, current amplifier, trans conductance and trans resistance. And we are having the 3 configuration. What are the 3 configuration in MOSFET? Common gate, common source, common drain. Here, when we are giving the input towards source, we are getting the output from the drain. It is the source. We are giving input to the source and output from the drain. This is the V2. This is not the input. This is the DC voltage, bias voltage. This is the input. Input to the source, output. So this is the common gate configuration. And what about this? This will act as a load. This will act as a load, guys. Then, when we are giving this type of circuit, whether it is common gate or common base, it is similar to what common base in case of transistor, BJT. Common base or common gate, both are what? Current controlled, current source. Current controlled, current source. For this circuit, input resistance is very low and output resistance is very high. Right? Input resistance is very low and output resistance is very high, and that's why it will act as a current controlled current source. Remember. So that is the case. Next one, D. Answer for this question is D, and it is similar to this. Common gate is similar to common base. Next one. Again, the question on what? Operational amplifier. Operational amplifier is, remember, very important topic. The V out by V in of the circuit shown below is. Tell me what will be the answer? V out by V in. V out by V in means it is a linear integrated circuit. 4 options are given: minus R4 by R3, R4 by R3, 1 plus R4 by R3, minus 1 minus R4 by R3. It is a inverting summer because there are R4 by R3, R4 by R3, it is connected to negative terminal. This one, the third operational amplifier, is inverting summer. And in a first operational amplifier, we are giving input to the non-inverting terminal. So it is a non-inverting operational amplifier. And here we are giving input to inverting terminal. That's why the second one is inverting operational amplifier. How we can find the output? Output will become minus R4 by R3 into Vx. What is the Vx? This is the Vx. And that this is the Vy. Minus R4 by R3 into Vx minus R4 by R3 into Vy. And that will become minus R4 by R3 Vx plus Vy. That is the output according to inverting summer. What is the Vx? It is a non-inverting operational amplifier and Vin is connected here. Therefore, Vx will become 1 plus Rf. Rf is R2 by R1 into Vin. And what is the Vy? Vy is the non-inverting Rf by minus Rf by R1 into Vin. Minus Rf by R1 into Vin. When we are adding these two, this term is cancelled out. So what is the Vx plus Vy? Vx plus Vy is nothing but Vin. So Vx plus Vy is Vin. So what is the V out by Vin? Minus R4 by R3. V out by Vin is nothing but minus R4 by R3. So this is the case, and what is the answer? Minus R4 by R3. Very simple question. Again, the operational amplifier is a very important one. Alright, so this is the, stay tuned with us, subscribe the channel, because we are solving the question for last 3 years. Again, we will solve the next 3 years, but these 3 years, 2023, 2022, 2021, that is very, very important one. Questions on what? Diode, right? Watch this diagram. In the circuit shown below, D1 and D2 are silicon diodes. If the silicon word is used, means what? It is a practical diode. With the cut-in voltage of 0.7 volt, V in and V out are input and output voltages in volt. V in and in out. This is the V in, V out. The transfer characteristics means V naught versus V out. How we can find transfer characteristics? Transfer characteristics, if you want to get, it is just like a diode. Then how we can solve? Watch this. What is this? 1 volt battery is connected here. What is the range of V in? You can start with what? Very high negative value. Any high negative value. This is the way to solve this question. You can put in table very high negative value. You can put -10, -20, -30. You can choose any value. And then you have to find what is the position of the diode here. For example, V in. You can choose -20, for example, V in less than or equal to. If this is a very negative value, highly negative value, very, very less than 1 volt, then definitely this diode D2 is on and D1 is off, because it will make it reverse bias. So what is the D1 off? What is the D2 on? When the D2 is on, it is replaced by a battery of what? 0.7 volt. So you will get the first diagram, just I am giving. This is replaced by a battery of 0.7 volt, and this is 1 kilo ohm, and that is 1 volt. And this is V in. Generalize, it is V in. And this is 0.7. And that is V out. From this, V out is V in plus 0.7. 0.7 plus V in. V in plus 0.7. And what is the slope of this line? 1. And what is the interception? 0.7. Okay, 0.7. So up now we are increasing the V in. When we are increasing the V in again and again and again, already it is forward biased by what? 1 volt. Watch this. Now always remember, when this diode will off, if suppose you want to check when this diode will off, then what is the current through this diode? Watch, what is the current here? So what is the current here? 1 kilo ohm. This is the 1 kilo ohm resistor. So what is the current here? Find the current. 1 minus V in. 1 minus 0.7 minus V in. 1 minus 0.7 minus V in upon 1 kilo. When this current will become less than or equal to 0, the D2 will off. So D2 will off. So when we are equating, you will get V in greater than what? 0.3. When V will greater than 0.3, diode D2 will off. D2 will off. So this range is up to what? 0.3. This is valid up to what? 0.3. Then when the 0.3 is greater than or equal to V in is greater than or equal to, this diode is off. This diode is also off. Why? Because already it is reverse biased by 1 volt and we are having only 0.3 volt here. If both the diodes are off, if suppose both the diodes are off, then what will be the diagram? This is off, this is off. And that is the resistor. This is the 1 volt battery. So you will get constant 1 volt here. Because there is no drop across this resistor, both the diodes are off. There is no connection between V in and V out. Output will become 1 volt. 1 volt constant. Then third, and this is valid up to what? If suppose you want to make this diode on, always remember, this diode is on the reverse side. Check the diode D1. We are having the 1 volt. On the positive side, we are having the V in. And this is a practical diode. This is called VP, this is called VN. The difference between the VP and VN should be greater than or equal to 0.7 volt. So what is the VP? Should be greater than or equal to 0.7 plus VN. And what is the VP? VN. It should be greater than or equal to 0.7 plus 1 means 1.7. So when the Vn is greater than 1.7 volt, D1 will on. That's why the breakpoint is 1.7. 1.7 is less than Vn is less than or equal to. Now you can go up to any positive value. This diode is on, this diode is off. It will remain off. Once this first diode is on, you can draw the circuit like this. 1 volt, this is the V out, this is 0.7, this is the V in. From this you will get the V out is equal to V in minus 0.7. V in minus 0.7 volt. V in, this is the 0.7 volt. So for this range, it will 1. Here the slope is 1, interception is 0.7. Here the slope is again 1, interception is what? 0.7. And up to what? Infinity it will work. No problem. That is the positive. So which answer? From 0.3 to 0.17, it is 1. So that is the answer. What is the interception here? 0.7. What is the slope here? 1. What is the slope after that? 1. If you are extending beyond, it will cut at minus 0.7. That's why option A is the correct one. I think now it is clear. So Amar, you have participated and you have given the answer for all the questions, and all other students, Sachin, right? So stay tuned with us and subscribe the channel, everyone. And now it is time, no doubt we have more question on that, right? For example, hybrid parameter, it is not in our syllabus, right? Hybrid parameter is not in syllabus, but we are having the question on hybrid parameter. But that question was wrong, marks to all. Marks to all question, because there is some mistake in this diagram. Unit is not given, proper diagram is not given. But remember, hybrid parameter is not in syllabus, but you have to get the command over that. In 2023, that was the question in hybrid parameters. Okay, basic question on hybrid parameters. Second, I am giving you the 1 and 1 and 1 homework only. Tomorrow we will solve. This is a homework assignment for you. Very, very, very easy question on current mirror circuit by using the MOSFET. Okay, very good evening, Kusum, right, and Praveen Kumar. So this is a question on current mirror circuit. Very simply, you will get the voltage at VL. This is the, we have to find the VL, right? VL in volt. That is right. Okay, all the questions are over here. So you are on BYJU'S exam prep, and you can join crash course, GATE 2024 crash course, complete syllabus coverage, live classes, recorded lecture, study material, practice quizzes, mock test. Some student asked, sir, is it possible within 4 months? Yes, it is possible. Yes, it is possible within 4 months. Okay, you are Nandesh Krishna. Good. Then that is for electrical branch as well as for electronics branch, guys. And this is my electronic channel, Telegram channel. I will upload the PDF of this session on my Telegram channel so that you can solve the question from 21, 22, 23 in my style. बहुत सारे क्वेश्चन सॉल्यूशन अवेलेबल हैं, बहुत अवेलेबल है मार्केट में, लेकिन अगर आपको क्वेश्चन कैसे सॉल्व करना है, आपकी स्टाइल क्या है, तो आप यहां से डाउनलोड कर सकते हैं. And you are on BYJU'S exam prep. Subscribe the channel, like the session, okay, and share the link of this session. Thank you very much for attending the session. Thank you.